Okay, so I decided to stop the video there. So I might have to do 3 videos. We'll just see how the rest of these examples go. But next, so now you should be comfortable with finding the z sub alpha over 2 scores. Okay, so let's look at example 3. I just rewrote the formula for the confidence interval because we're going to be using it throughout most of these problems. So let's look here in example 3. So since 1975, the average fuel efficiency of U.S. cars and light trucks has increased from 13.5 to 25.8 miles per gallon, an increase of over 90%. A random sample, so while I'm talking, I also will be writing, and you should too. And in fact, you should pause the video and just set up your values. So see if you can set up your n, your x bar, your standard deviation, and then your z of alpha over 2. Okay. Welcome back. All right. So you should have had that n is 40, x bar is 28.1, and the standard deviation is 4.7. And since we know, so we want a 95% confidence, then that tells us that our z sub alpha over 2 will equal 1.96. Okay, and if we just plug this in the formula, so the setup would look like 28.1 minus 1.96 times 4.7 divided by the square root of 40 minus mu is less than 28.1 plus 1.96 times 4.7 over the square root of 40. Okay, pause this video and put your calculations in and see if you come up with the same answer. All right, so you should have received this interval here. 26.6 is less than mu, is less than 29.6. And always make sure you write your conclusion out. So thus, with 95% confidence, the true mean gas mileage will be between 26.6 miles per gallon and 29.6 miles per gallon based on a sample of 50 cars. All right, hopefully that was clear. Let's move on to the next example. Okay, so example 4 is asking a different question. So let's look. So a sociologist wishes to estimate the average number of automobile thefts in a large city per day within 2 automobiles. He wishes to be 99% confident, and from a previous study, the standard deviation was found to be 4.2. How many days should he select to survey? So now you're not given the sample size. You're trying to find out, depending upon how confident you want your data to be, what should you make the sample size? And here's the formula. So this is a formula for the minimum sample space needed for interval estimate of the population mean, so n. Notice that z alpha over 2 is still in there. So n equals, in parentheses, z sub alpha over 2 times our standard deviation divided by e. And E represents the margin of error. That's what E is representing, okay? So in this example, we see that, or you should hopefully see that E is 2, okay? Because it says to estimate the average number of automobile thefts in a large city per day within 2 automobiles, okay? So E is 2, Z sub alpha over 2. If you do the calculations, and I'm going to leave this for you to do, but double check, Z sub alpha over 2 should be 2.58, okay? So double check the process, that 4-step process I gave you. Double check to make sure you understand that where I received that 2.58 from. And then our standard deviation is 4.2, okay? So if we plug in this information into the formula, all right, so plugging in our given information and then plugging it into the formula, you should get about 29.35. Okay, and for, I'm going to say it and then I'll write it out, but for when you're asked to find the sample size, you round off instead of up, and you round up instead of off. So we've been rounding off. So rounding off is when we have like 26.5, we'll round that to 27 if we're doing, so if we have like 26.5, we'll round that to 27, right? This is, you don't have to, I mean, you can write this sort of on the side, but I'm going to erase it in a minute. So 26.5, if you round off, you would round it off to 27, or 26.2, you would round that off to 26, right? But now if you're rounding up, so here's the difference. 26.2, I'm sorry, rounding up, 26.2 becomes 27. Okay, so I want to be careful because I think in other problems we've rounded up, and in a lot of problems we round off. Mostly we round off. So if it's 5 or higher, you round to the next number. If it's below 5, you keep that number the same. But if you're rounding up, which you will be doing whenever you're asked to find the sample size, then you round up. So it would be 27. So in our example, it's going to be 30. Okay, so I'm going to write that down. All right, so to conclude then, to be 99% confident that the estimate is within 2 vehicles of the true mean, the sociologist needs to sample the test for at least 30 days. So we got 30 days because we rounded up to 30 and not off, which would be 29. Hopefully that makes sense. Let's move on to the next example. Okay, so this example is actually putting together what we've been talking about. So I want you all to see if you can set up and actually go through this problem. Pause the video and see if you can go through this problem on your own. Okay, welcome back. And now that you've completed this example, let's go over it. A, again, the best point estimate of the population mean is always the sample mean, so it would be 7.2 jobs. B is to find the 95% confidence interval, which we know that means our Z sub alpha over 2 is 1.96. N is 50, X bar 7.2, and standard deviation is 2.1. So if we plug it into our formula we have for the confidence interval, you should have received that mu is between 6.6 and 7.8. Okay, and then C, find the 99% confidence interval of the mean number of jobs. Here, the N, X bar, and sigma stays the same, but now your Z sub alpha over 2 is 2.58. Plugging that into your formula, you should have received mu is between 6.4 and 8.0. Okay, now question D, which is smaller? And they're referring to between B and C, and explain why. Okay, this is actually going to be your quiz question, second quiz question from the video. The first will be a definition, like I said early in the first video, and now this is going to be quiz question. It might not be number 2 in your lineup, but it's number 2 from the videos, because you're going to have questions from 6.2 and 6.3 that we went over in class, and then you're going to have some questions here. So keep watching the video. It might be another question, or maybe not. I don't know. I do know, but I'm not telling you until the end of the video. Okay, so answer that on your own. Just think about why, and actually the answer to this is in your book. It's directly in your book. It may not be verbatim because I want you to read this section over, but the answer to this question is in your book. There's a reason why one is smaller than the other, so I want you to answer that. So there's going to be an open response. This won't be a multiple choice question. This is going to be an open response question where you'll have to write in your answer to that. Okay? All right, last but not least is example 6. So in example 6, I forgot to put the data values in, so please put in the data values. But here we have a random sample of the number of farms in thousands in various states that's following below. So these are the number of farms. It's in thousands, but it's written like this. So 47 corresponds. So this 47 is actually like 47,000. Estimate the mean number of farms per state with 90% confidence. Assume the standard deviation. Assume sigma is 31. Okay, so notice here you were not given the sample mean, so there's no X bar given directly. However, you're given the data points, and there should be, I just want to make sure you can understand my writing. So 47, I'm going down each column so you can make sure you wrote the numbers correctly. 47, 8, so 47, 8, 68, 29, 95, 97, 54, 3, 15, 33, 49, 21, 64, 4, 52, 4, 44, 6, 8, 79, 78, 57, 80, 109, 9, 48, 40, 80, 16, 50. All right, so you have those values. It should be 31, I believe. You can use Excel to put in these data values and, ask for the average and calculate your sample mean. That way you can put these numbers in it. If you put them in your calculator, which you can do, be very careful to not make an error. And I would suggest, if you put in your calculator, to try it 2 times, at least 2 times, to make sure you put it in correctly. But what I want you to do is finish this problem. So this is going to be, your question 3 will be, what is the confidence interval? So what's the interval? Where's the true mean population between for this data? So you actually will be doing this on your own. I'm not going to do this with you. And this is going to be the 3rd and final quiz question from this section. All right, I'm not for sure. You probably have 7 or 8 questions total for the quiz. The remaining questions will come from 6.2 and 6.3, so I might pick 2 and 2 problems for quiz 2 or 3 problems from each section, or I don't know how I'm going to do that. You'll have no more than 10 questions, but at least I think 7 or 8 total. So, but you only have 3 from this section, which I've given you. I didn't give you directly. Well, the definition. So the definitions, again, make sure you write all the definitions in first before you start the quiz, because it's a time quiz, and I don't want you wasting time trying to find the definitions. So complete the definitions, complete this example, and complete the other question I asked you about, explaining why it is smaller. All right, so hopefully this video made sense. We are done. I only needed to do 2 videos. I will see you all when I return, and happy studying.